Hey everyone, it's Davi. Today I'll show you a simple and effective method to calculate read and write capacity units for DynamoDB. Once you master this method, you will be able to calculate RCUs and WCUs for any situations and easily solve AWS questions that involve these calculations. But before we start, let's understand what these numbers mean. DynamoDB charges based on read and write capacity units mean that the cost depends on the amount of data read and write per second. If you use on-demand mode, you don't need worry about capacity. It automatically scales, but if demand increases, your bill can skyrocket. That's why many people prefer the provisioned mode, where you set fixed limits. To do that, you need to know your demand and calculate how many units are required. Once you understand this logic, calculating RCU and WCUs becomes super easy. Here's the step-by-step method. Step 1. Identify whether the demand is read or write. One strongly consistent read unit handles 4 kilobytes per second and one write unit handles 1 kilobyte per second. Step 2. Identify size of the demand. Step 3. Calculate how many units are required to handle the demand. Step 4. Identify the time period of the demand in seconds. Step 5. Multiply the calculated units by number of operations per second. Step 6. If it's eventually consistent read, divide the result by 2, because eventual reads consume a half of many units as strongly consistent reads. And here's a pro tip. Do the math as if it's strongly consistent and only divide by 2 at the end if it's eventual. Now let's practice with some real AWS starter questions. As a full-stack web developer, you are involved in all aspects of your company platform, for PHP and JavaScript development to NoSQL database using Amazon DynamoDB. You don't worry about receiving stale data and read to perform 16 eventually consistent reads per second, each of 12 kilobytes. How many reads capacity units, RCUs, do you need? Step 1. Demand type. Read 4 kilobytes per second. Step 2. Demand size 12 kilobytes. Step 3. Units required. 12 divided by 4 equals 3. We need 3 units of 4 kilobytes to handle the demand of 12 kilobytes. Step 4. Demand type 16 reads per second. Step 5. 3 times 16 equals 48. Step 6. Eventually consistent. Yes. Divide by 2. 48 divided by 2 equals 24. Answer. You need 24 RCUs to handle this demand. Next question. Company B writes 10 items per second, each 15.5 in size. What is the required write capacity for best performance? Step 1. Demand type. Write 1 kilobyte per second. Step 2. Demand size 15.5 kilobytes. Step 3. Units required 15.5 divided by 1 equals 15.5, around to 16. We need 16 units of 1 kilobyte to handle the demand of 15.5 kilobytes. Step 4. Demand time 10 writes per second. Step 5. 16 times 10 equals 160. Step 6. Not eventual. Answer. You need 160 RCUs to handle this demand. Next question. How many read capacities units are required for strongly consistent read of an item up to 80 kilobytes? Step 1. Demand type. Read 4 kilobytes. Step 2. Demand size 80 kilobytes. Step 3. Units required 80 divided by 4 equals 2. Step 4. Demand time 1 read per second. Step 5. 2 times 1 equals 2. Step 6. Not eventual. Answer. You need 2 RCUs to handle this demand. Next question. Your application will read 10 items per second, each 6 kilobytes in size, with strongly consistent. What's the required read capacity? Step 1. Demand type. Read 4 kilobytes per second. Step 2. Demand size 6 kilobytes. Step 3. Units required 6 divided by 4 equals 1.5, run to 2. we need 2 units of 4 kilobytes to handle the demand of 6 kilobytes. Demand time, 10 reads per second. Step 5, 2 times 10 equals 20. Step 6, not eventual. Answer, you need 20 RCUs to handle this demand. Final questions, the most challenging one. You create a provisioned DynamoDB table. You want to read 60 items per second for each 6 kilobytes and write 80 items per second each 1.5 kilobytes. Which the following defines the correct provisioning capacity to avoid trolling. Step 1, demand type, read 4 kilobytes per second and write 1 kilobytes per second. Step 2, demand size, 6 kilobytes for reads and 1.5 kilobytes for writes. Step 3, units required, reads, 6 divided by 4 equals 2. We need 2 units of 4 kilobytes to handle the demand of 6 kilobytes. Writes, 1.5 divided by 1 equals 1.5 write 2. We need 2 units of 1 kilobytes to handle the demand of 1.5 kilobytes. Step 4, demand time, reads 60 per second, writes 80 per second. Reads 2 times 60 equals 120, writes 2 times 80 equals 160. Step 6, not eventual. Answer, 120 RCUs and 160 WCUs to handle this demand. That's it, you guys. If you like it, don't forget to give the thumb up and hit the subscribe button. Thanks for watching.